So in Vectors Assignment 5 you had 2 questions to do, and this was all about being able to divide a line in a ratio. So begin by looking at the first question. So you've got 2 points here, A and Q, and you've got a point that's part of the way between A and Q, and in fact it's dividing the line in the ratio of 2 parts to 1 part. So you can see I've drawn out a line here. I've actually put my coordinates on to the end of the points, and then I've positioned my point P part of the way along, and I've got my X, Y, Z for my coordinates. I'm also going to put in a little cross here because that can help us with our thinking through our diagram. But the first method I'm going to look at is the one where it's making use of the ratio that you've written down, and we're going to write down the statement that says A to P compared to the vector to go P to Q. In terms of their length, there is 2 parts compared to 1 part. If I then cross multiply here with this, then I can see that I can write down that A to P is in fact 2 times P to Q. Now remember, it's the point P I'm trying to find, so all I've done at the moment is use the ratio to get to this statement. Now what I'm going to do is I'm going to use my position vector result, and I'm going to write down that A to P is the same as P minus A, and P to Q is the same as Q minus P. Then what I need to do is multiply out my brackets. So I'm going to have 2Q minus 2P. Now my aim is to get the position vector P on its own and get a value for it. So if I collect this bit of algebra here, collect all the P terms on one side, I'd end up with 3P is equal to 2Q plus A, or A plus 2Q. And now what I'm going to do is I'm going to use my components. I've still got that 3P there, I'm just leaving it there just now, and I'm doing 2 times the components for Q, where 3, 2, 8. Remember, components are the same as the coordinates, and you've also got the components for the point A, where minus 3, minus 1 and positive 5. I will multiply that first bracket, so I'm getting 6, 4, 16. And I've got minus 3, minus 1, 5, and I'm then going to add those 2 things together, so I get 3, 3 and 21. So from that, remember that this is what 3P is equal to, so we're then looking to divide through, or take a third of that, which means that P would be equal to 1, 1, 7. Now remember, that's the position vector, so the coordinates of the point P would be written out along the way, so 1, 1, 7, and that would be your final answer. So that is just one method, that's using the line ratio, and also using position vectors to do that. Alternatively, method 2 is the section formula, and the section formula is where I'm going to work out each of these coordinates for the P point individually. So I'm going to work out the X coordinate first, and I can do that by using the 2, so this is why I've got the wee cross in. I'm going to do 2 times the X coordinate of the Q point, plus I do 1 times the X coordinate of the A point, so 1 times minus 3, but on the bottom, right, it needs to be that if you've got a line split up in 2 parts to 1 part, that's a total of 3 parts going on there, so you will be dividing by 3, so you end up with your X coordinate for P on the top there, you get 6 minus 3, so you get 3 over 3, which means that that is equal to 1. You would do exactly the same thing with a y coordinate. So with your y coordinate, you're going to be doing 2 times your 2 plus 1 times the minus 1. So on the top of our line there, we would have 2 times 2 plus 1 times minus 1, and on the bottom we're all dividing by 3. That also gives you 4 minus 1 on the top there, which is 3 over 3, which equals 1. So that's our y coordinate, and then our z coordinate will be worked out by doing 2 times the z coordinates of each of the points, 1 times the of the 1 point, and then 1 times the 5 all over 3. That gives you 21 over 3, which means 7. So we end up with the coordinates for P being 1, 1, 7, and that was what we got before with the alternative method. So it's entirely up to you which method you are happiest using, which one you're most likely to remember and be able to work with. So in question 2, the only difference here is that we've been given the position vectors rather than the coordinates of the point. But again, it is about dividing the line. But of course, if you're given the position vector, you should be able to write down the position vector in terms of its components. So I direction, that would be your x. Y direction, remember, is your y, so the coefficient there is 1. And then the z direction would be the minus 4. So the point, so position vector for A has components 3, 1, minus 4, which means the point A has got coordinates 3, 1, minus 4. And then for B, you would have minus 2, minus 9, and 1. And again, that would give us a point with coordinates minus 2, minus 9, 1. So this time, drawing out your line, I would write in the coordinates here, and I'm also going to use the section formula to do this question, but you could use the other method. So I'm going to write down my ratio underneath. This time it was being divided by 3 to 2, so your little crossover. And just to remind you that you're working out the x coordinate for P by doing 3 times the minus 2 plus 2 times the 3, and that's all over. Now this time the bottom of my fraction needs to be 3 plus 2, total of 5 pieces for that. So I end up on the top of that with minus 6 plus 6 over 5, that's clearly 0 over 5, which is going to give me 0. For the y coordinate, I would be doing 3 times minus 9 plus 2 times the 1, the y coordinate, and that is all over 5. So that's going to be minus 27 plus 2, so that is minus 25 over 5, which is minus 5. Your z coordinate is then worked out by doing 3 times the 1 plus, you're going to have 2 times the minus 4 all over 5, and that gives you 3 minus 8 on the top there, which is minus 5 over 5, which is minus 1. So that tells us that the coordinates of the point P will be 0, minus 5, minus 1. So make sure you write the coordinates across the way and not like components. You could of course have done that by the other method where you would have written down your fraction A to P and P to B. So I tend to think the section formula quite a quick way to do that, but sometimes it is more appropriate to use the other method. It's just entirely a personal choice.